Okay, we're back. We're going to start further talking about our parametric equations, and we're going to look at some other alterations. I'm going to say to you, what is going to happen when I switch these up? Now, typically the x was named as the cosine and the y is named as the sine. Now, you should well imagine that um, if I eliminate the parameter, divide by 2 and square both sides, I'm going to get this as my equation of the circle. So that equation of the circle shows no difference than if this were written x cosine, x equals 2 cosine, y equals 2 sine. So, so what is the difference? Well, the difference is not going to be illustrated here with uh, the functional equation, but it will be illustrated um, with the parametric equations as the graph is being constructed. So here's the end result, and to that extent we have to go to the calculator, which means I have to go to another video to discuss that, but we'll demonstrate that with another video. Okay, so eliminating the parameter really does makes this expression static. That's what you're going to appreciate about parametric equations, is that they're dynamic. They actually occur in time because they're dependent on a third variable. So um, in essence, that third variable could be construed as time, and in many cases is. Okay, not with these sets of parametric equations, but the calculator is going to illustrate it as such, and we'll see that in the next video. Okay, so if you're going to plot points, allowing t to equal 0, well, of course, we'll give you a coordinate 0, 2, which means that the circle is going to start being graphed with this being the first point plotted. Okay, um, and at t equals 90, when we put it in, we get the coordinates of 2, 0. So the second point is going to be graphed here. So you're going to find that this, when the graph is going to start here and go, okay, counterclockwise, go counterclockwise, counterclockwise. Whereas in the previous points, it started here and went clockwise this way, counterclockwise. Now, you might ask, well, how can I have that thing going counterclockwise? Well, I think if you assign one of these a negative, you'll see what happens on that front. Okay, we'll play with that in the calculator. All right. Um, so you do see, well, you don't see so much here, but you will when we execute the calculator with some of these parametrics. That the parametrics are more dynamic than the functional. We're going to try something else here. We're going to say, well, let us say that you put this in the same previous equation or original equations, but we use a half angle. So what happens here? Well, when you graph, you see you will only see a half semicircle. And why is that? Well, it's really not because of the half angle, although in a sense it is, because look what happens if we put in points. Okay, when you put in 90 degrees or pi over 2, it's actually taking half of it and making it a pi over 4, so you're getting that pi over 4 value graphed, okay, right there. So by the time it comes around to 2 pi, it's actually evaluating at 1 pi. So to resolve that, what we could do is we could change the window setting, come back here, and we notice that our window setting is typically set here at 2 pi, so we could kick that up to 4 pi, in which case we get a full revolution around. Okay, and again, we'll illustrate that with your calculator. All right. Um, as we had mentioned previously, the t-step was set at pi over 24, which is 7.5 degrees. So um, when you are graphing a circle, and if you go back and you say, well, let's graph 2 cosine x equals 2 cosine y equals 2 sine, then you're actually not graphing a circle. You're graphing a multi-sided polygon, and in this case, well, you're graphing 24 sides on a half circle, so you're graphing a 48-sided polygon. So if you alter that, then you can if you alter that, then you can graph more polygons of sort. Now, say, and that's done with the t-step. So my suggestion is that we go and we explore what happens when we change this t-step. Now, this illustrates a t-step of 2 pi over 3, which means, okay, basically, we're plotting points every 120 degrees. So we start here, okay, go to 120, go to 240, 360, and you're done. Okay, so make a hypothesis about what's going to happen, what kind of polygon is going to be generated with these kind of t-steps. Okay, and again, we'll illustrate that with the calculator. And as I said, why don't you try this? This will look real cool. The t-step set at 2. Okay, and the T-max going to 24 pi. We'll actually take a look at that and show you on the calculator, but as for